In this video, we'll be determining some characteristics of the sine or cosine function based on its equation, not the graph. So the function that I'm given here is y equals 3 sine 2 outside of x minus 45. So I'd like to compare that to my base function, which is y equals a outside of sine b x minus c plus d. So recall that the a value here represents the amplitude. The b value is going to affect the period. The c value represents our phase shift. And the d value is the equation of our midline. So when I'm looking for the amplitude of this function, I just need to look at the value in front of sine here, which is 3, so the amplitude is 3. The equation of my midline is represented by d. I don't actually have a d value here, so the equation of the midline here would be y equals 0. For the range, I want to look at finding the max value and the min value. So if I know where the midline is, and I know how large the amplitude is, the max should be 3 away from the midline, or 3 above it. So the max should be 3, which means the minimum should be 3 below it. So I get a negative value there. So my range ends up being y is going to be between positive and negative 3. The period of this graph is the result of the b value. So since b is 2, things are going to happen twice as fast here, meaning that the original period needs to be divided by 2. So let's take 360 and divide it by 2. So the new period is 180 degrees. And the phase shift, remember, will be the opposite of the value we see in our equation because we have a minus c here. So since we have minus 45 in the function there, the phase shift will actually be 45 degrees to the right. And finally, when we want to compare the graph of the cosine function and the sine function, where in one case we're subtracting 45 degrees, in this case we're adding 45 degrees, we want to know how they would be the same or different. They're going to have the same period. They're going to have the same midline. They'll have the same range. They'll have a lot of things the same. But the location of max and min values will be different. Because our original graph of y equals sine x and y equals cosine x are out of phase by 90 degrees. If we have the period of both of those, they'll be out of phase by 45 degrees. So if we had just y equals cos x and y equals sine x, we'd have a 90 degree phase shift. In this case, if we didn't have the 45 here and the 45 here, we'd be out by 45. But what we've done now is we've moved the sine function 45 degrees to the right, and then we've moved this 45 degrees to the left. So we've actually increased that phase shift by another 90 degrees. So the two of these would be out of phase by 135 degrees because we've got that base of 45 plus 90. So the two functions are 135 degrees out of phase.